Shaders are used to change the appearance of objects by affecting how textures are applied, how lights interact with the objects, and more. There are two main approaches to shaders in Unity: shader scripts and shader graphs. Shader scripts are a code-based approach to creating shaders, while shader graphs provide a visual format for shader editing. They can both be used to accomplish similar effects, but shader graphs seem to be the most commonly used approach in modern Unity because of their ease of access. Shader graphs still have corresponding code, but just by looking at it, you can see why people prefer the visual option. This project uses Unity's universal render pipeline, and shader graphs are automatically included with URP. With that out of the way, let's get into the examples. We'll start with unlit shaders. They're called unlit because they're not affected by environmental lighting. These first two shaders were made using shader code just to demonstrate what that looks like, but all the rest were made with shader graphs. The first one has a property, which is like a serialized field, and we can make shaders into materials by right-clicking the shader, and from here, we can apply it to an object and adjust the color. The second one is similar, but now we have a property for the texture. Next, we can see a lit texture shader made in shader graph. You can tell it's lit by the shading on its sides and the slightly reflective surface. We can turn the shader graph into a material through the same process. And to make the properties appear in the inspector, we just have to add them to this box in the shader editor. Here we have a color inverse cube. You can choose which color channels to invert, and this one has all of them inverted. For a metallic look, you can adjust the metallic and smoothness properties in the shader graph to increase light reflection. Here I just have them both maxed out. Transparent shaders require a slightly different property. Inside the graph setting, you can see a field called surface type, and this can be changed to transparent. From there, you just have to adjust the new alpha value to alter the transparency. Here's a transparent cube that takes two color inputs, one for the color of the material and another for the hue that it projects onto the background. This one has a blue background hue. This next effect is called the Fresnel effect, and it has a specific node that allows you to edit the color of the light that is reflected off of the object. You can see a golden light reflection on this cube. On the topic of lighting, the glow effect of this cube is achieved through post-processing. For this, you just need to use a color that uses HDR, adjust the intensity properties, and make sure you have a global volume and bloom post-processing created in your scene. These next two cubes use a property called depth testing, which we can expose by checking this box in the shader graph. The first cube is only seen when it is behind another object, and the other cube is always rendered on top of an object regardless of its position. Alpha clipping or cutoff allows us to make certain parts of a texture transparent, and it is enabled here in the shader graph. In this example, the dark areas of this texture are made transparent. By using time and tiling and offset nodes, we can make textures have a scrolling effect, and this is how it looks combined with alpha cutoff. Now is a good time to mention, if you want further detail on how these shaders work, I recommend checking out this channel for learning more about shaders. Many of the shaders featured here are based on his videos, and he gives very good explanations of how the shaders actually work and how to build them from scratch. This shader combines the scrolling we just saw with a glow effect. With the right textures, it can make a cool looking force field. Dithering is a kind of small dotting effect that when combined with alpha cutoff can create an appearance like this. This is also paired with a sine wave, which creates the fading in and out. In this dissolving effect, I selectively apply gradient noise to the alpha channel and combine it with sine time to create the fading. This next one is similar, but with two key differences. I apply some scrolling to the gradient noise to create a kind of fizzy look, and then I add an emission color channel for the glow, which is the same HDR glow thing used for the glowing cube. These next two are a bit weird. They both use a texture that is tied to a custom Unity node called a flow map, which creates the swirly effect. These two examples are basically the same, they just use different noise types. Pretty sure this one started whispering to me after I stared at it for a while. This one accomplishes a more dynamic scrolling effect with UVs and noise. This shader applies a pixelated effect. It essentially creates a checkerboard pattern over the texture. A cel-shaded effect can be achieved by choosing a custom light direction in addition to some other stuff I don't totally get. Looks neat though. This cube changes its vertices depending on how you look at it. It can be a good idea to handle some vertex displacement with shaders because shaders run on the GPU, and this can save performance. I think a shader similar to this can be used for a grass bending effect when players move near it, for example. This next cube turns itself according to player camera by using a node called Billboard. If you've seen some 3D games that have 2D sprites which face you, it uses an effect similar to this. This wave effect is also made through vertex manipulation. We pretty much apply a sine wave to the world and object positions of the cube. Here you can see the actual collider of the cube remains untouched, meaning this is all visual. This is also a wave pattern, but it's based on a type of wave called a Gerstner wave. This node is also provided in the Unity examples. This cube does a kind of angry, jello-y shake using vertex displacement. We don't talk about this one. These two are the same shader applied to a sphere and square. It creates a kind of vertex break effect by applying noise to the vertices. You can edit height maps and normal maps through shaders, which can create the illusion of depth and height on a flat surface. Now we have intersection shaders. These cubes have the edges of their intersection highlighted when they collide with another object. In the first cube, it's mostly just a shadowy effect. And here you can see it combined with alpha cutoff, so only the intersection and not the cube itself is visible. This has one other additional property checked here, which allows us to see both the front and back-facing intersections. Lastly, we can add glow to the cube edges to get a cool glow effect at the intersections. The most common example that people reference for this kind of shader is Reinhardt's shield in Overwatch. To end, in the middle of the museum I have an example of stencil buffers. This takes a bit of work to set up, so I'll leave a recommended video in the description. But the general idea is that there are 4 invisible windows and 1 object for each window, and the objects can only be seen when they are looked at through the invisible window. If any of you have played Antechamber before, they make use of this effect. One last handy tip: if you want to look at some shader presets made by Unity, you can go to Window, Package Manager, search Shader Graph, go to Samples, and then Import Samples. They have a lot of notated shader info to help you learn about shader nodes. I hope this video gave some insight into what is possible with shaders. I knew next to nothing about them just a couple weeks ago, so I tried to share the things that stood out the most to me in my learning process. If you want to create new shaders of your own, I definitely recommend checking out some of the channels in the description. Also in the description, you can find a link for touring around the Shader Museum, as well as a download for all the shader files themselves, so you can import them directly into your project. Thank you all for watching the video and your continued support of the channel. Until next time.